November 2nd, SpaceX's Falcon 9 roared to life, carrying something NASA never saw coming. Not a satellite, not a cargo mission, but Haven Demo, a full-scale prototype for the world's first private space station. Within minutes, telemetry confirmed. Every system online, solar arrays deployed, orbit stable. What does this mean for the future of human spaceflight? Welcome to Space Update 24 Hours, where we break down how Vast and SpaceX just rewrote the rules of orbital infrastructure. Let's dive right in. So what exactly was sitting inside that Falcon 9 fairing? Haven Demo isn't just another test article. It's a full-scale dress rehearsal for humanity's next chapter in space. Every critical system needed to keep astronauts alive. Power generation, propulsion, navigation, thermal control, communications, all packed into one orbital testbed. And here's the part that should worry NASA's old guard. Vast built this entire spacecraft in just 2 years. 2 years. From concept to launch-ready hardware. How is that even possible when traditional space station modules take a decade? The answer lies in Vast's DNA. This isn't your grandfather's aerospace company. Instead of endless review boards and risk-averse committees, Vast operates like SpaceX. Build, test, break, rebuild, repeat. Their facility in Redondo Beach handles everything in-house. Manufacturing, integration, testing. No waiting on external contractors. No bureaucratic black holes where schedules go to die. When an engineer spots a problem at 2 a.m., they can walk to the manufacturing floor and fix it before sunrise. That's the speed advantage legacy companies can't match. But speed means nothing if the hardware fails. Which brings us back to November 2nd, T-0. Falcon 9's 9 Merlin engines ignited. The rocket climbed through a perfectly clear Florida sky. Stage separation confirmed. Haven Demo coasted into its target orbit at 17,500 miles per hour. Then came the silence. Mission Control in Long Beach held its breath. Every engineer in that room knew the brutal truth. Launch is the easy part. Surviving it is what counts. 60 seconds passed, then 90. The spacecraft had to wake up on its own, deploy its solar arrays, establish attitude control, and phone home, all while tumbling through the vacuum at 5 miles per second. If anything went wrong, if a single circuit board cracked during ascent, if one deployment mechanism jammed, the mission was over. Then a voice cut through the tension. We have telemetry. Data flooded the screens. Solar arrays, deployed and generating power. Attitude, stable. Battery charge, positive. Communications, locked. The room erupted because this wasn't just a successful deployment. It was validation that Vast's approach actually works. Haven Demo will spend the next 6 months proving it can survive. Radiation exposure, thermal cycling between 250 degrees Fahrenheit in sunlight and negative 250 degrees Fahrenheit in shadow. Micrometeorite impacts, orbital debris. Every failure mode that could kill a crew habitat will be tested and documented. And if it survives, then Haven 1 gets the green light for its May 2026 launch. But what exactly is Haven 1, and why should you care? Picture this, 45 cubic meters of pressurized volume, about the size of a city bus, 4 sleeping berths, 1 massive observation window, a microgravity research lab. And here's the kicker, it's entirely privately funded and operated. No government contracts keeping the lights on. Vast CEO Max Hayat has been brutally honest about Haven 1's purpose. It's not a space hotel. It's not a luxury resort. It's a productivity machine. A place where astronauts can work harder, rest better, and push the boundaries of what's possible in microgravity. The first crew mission, Vast 1, is scheduled for late June 2026. 4 astronauts, 14 days, riding up on SpaceX's Crew Dragon. But there's a problem most people don't talk about. Haven 1 has no life support system of its own. The Crew Dragon provides everything: oxygen, water reclamation, CO2 scrubbing. That's both brilliant and risky. Brilliant because it cuts development costs and timeline in half. Risky because if Crew Dragon has an issue, the entire station becomes uninhabitable. It's a calculated bet that SpaceX's hardware is reliable enough to stake lives on. So far, that bet has paid off. Crew Dragon has flown over a dozen missions without a single life-threatening failure. But statistics don't eliminate risk. They just quantify it. Right now, Haven 1's primary structure has already passed pressure testing at VAST's Mojave facility. The flight qualification article, essentially a structural twin that gets tortured to death so the real station doesn't have to be, has survived load tests simulating 3 years of orbital stress. Next stop, NASA's Neil Armstrong Test Facility in Ohio, where Haven 1 will face acoustic bombardment, vibration tables, thermal vacuum chambers, and radiation exposure that would turn most hardware into expensive scrap metal. Only after passing every nightmare scenario will it ship to Cape Canaveral for final integration. And this is where the SpaceX partnership becomes critical. VAST builds the station. SpaceX provides literally everything else: launch vehicle, crew transport, communications through Starlink, ground operations, training. Even the docking mechanism is SpaceX hardware. It's a vertically integrated supply chain that would make Jeff Bezos jealous. But more importantly, it's proof that commercial spaceflight has matured beyond the billionaire space race headlines. This is infrastructure. This is sustainable. This is the foundation for something much bigger. Because Haven 1 is just the proof of concept. The real goal is Haven 2, 8 interconnected modules, assembly beginning in 2028, full completion after 2030. And when it's done, Haven 2 will feature something that will redefine what it means to look back at Earth. A panoramic observation window 12.5 meters wide. For context, the ISS's famous cupola is 3 meters across. This will be 4 times larger. The views will be absolutely unprecedented. But here's the reality check. VAST isn't alone in this race. Axiom Space is building their station with the first module launching as early as 2025. Blue Origin and Sierra Space are developing orbital reef with backing from heavy hitters like Boeing and Genesis Engineering. Northrop Grumman is partnering on Starlab with Voyager Space, and they're all competing for the same prize. NASA's Commercial LEO Destinations contract, expected to be awarded in 2026. The winner gets a cornerstone customer with deep pockets and a guaranteed market. The losers? They'll need to find private customers willing to bet millions on unproven hardware. NASA has fundamentally changed the game. Instead of building its own stations, the agency will become a tenant, a customer renting space on commercial platforms. This frees up billions for deep space exploration, Artemis, Mars, beyond. But it also creates a Darwinian selection pressure on the private sector. Only the fastest, most efficient, most reliable companies will survive. And right now, VAST has momentum. They've got working hardware in orbit. They've got a proven launch partner. They've got a clear roadmap from proof of concept to operational station. The question isn't whether commercial space stations will replace the ISS. They will. The ISS is scheduled for deorbit in 2030. The question is, which company will be ready when that happens? Which station will become humanity's new outpost? And can VAST maintain their lead long enough to win the contract that makes or breaks their entire business model? So here's where we stand. Haven Demo is circling Earth right now at 5 miles per second, proving that a lean team of 200 engineers can do what legacy contractors said was impossible. Every hour it survives in orbit is another data point showing that commercial space stations aren't science fiction anymore. They're engineering reality. And in 18 months, if everything goes according to plan, the first private astronauts will wake up inside Haven 1, look through that massive window, and see Earth from a vantage point that was exclusively government property for 6 decades. But this story is far from over. Axiom, Blue Origin, Northrop Grumman, they're all racing toward the same finish line. And honestly, that competition is exactly what we need. Because when the ISS splashes down in 2030, humanity needs a backup plan. Multiple backup plans. The companies that move fastest, build smartest, and survive the brutal economics of orbital operations will write the next chapter of human spaceflight. The clock is ticking, the hardware is flying, and the future is being welded together in facilities from California to Ohio right now. What do you think? Will VAST win NASA's contract? Or is another company going to surprise everyone? Drop your predictions in the comments below. If this breakdown gave you a new perspective on the commercial space race, hit that like button and share it with someone who still thinks space is just for governments. And subscribe to Space Update 24 Hours, because we're tracking every move in this high-stakes competition. The next big announcement could drop tomorrow.